What's up, everybody? Good morning, and welcome back to another live stream from Scaled Learning, where we are tackling SAT problems, math problems, straight from the source, straight from Khan Academy. So without further ado, let's do it. Today we are tackling percents, and let's get right into it. Now, if you're new to the channel and you haven't seen these videos before, I'm doing all of these for the first time. Without any preparation, which is part of the fun. And also the reason is so that you can see what it's like to problem solve in real time. So here we go. A high school student's graduation rate is defined to be the percentage of the senior class that graduates. Last year, 406 of the 452 graduated. This year, the school expects the previous year's graduation rate to increase by approximately 2 percentage points. If there are a total of, so first of all, let's calculate this percentage, and this is a calculator problem. We can set up a nice proportion like that, or I can just divide this and move the decimal over, either way. So 406 divided by 452 equals 0.89. 89.82%, let's say. Sure, we got the numbers right. 406, 452. Okay, 89.82%. They expect the percentage to raise by 2 percentage points. So we could say it's going to be 91. I'm using my percent proportion, 91.82 out of 100, and this equals X, right? So it's supposed to go up to this, and then the question is, what is 91.82% of 436? We can do a little cross multiplication. 1.82 times 436. 40,000, whatever it is, 40,000, 0.52, right, equals 100x. Now we're going to divide both sides by 100. And it's 400 roughly. Okay, boom. All right, next. A software distributor charges 41 per license of a particular utility. The distributor offers a 10% discount on each license after the first 20. Okay. How much would a business pay for 40 licenses? So it's like 20 times 40, because we get the first 20 licenses at the regular price plus 20 times 0.9 times 41. Okay, because this is 10% off. If it's 10% off, I'm trying to take a shortcut here when I set this up. If this is 10% off, I'm really only paying 90%. So I can just say, oh, it's 0.9 times 41, and then 20 of those. So let's see. This I can do in my head, right? This is $820 plus. Actually, I could do this in my head too, I think. So this is going to be 800. Actually, this is going to be 820, and then 10% of that is 82. So 738. So what I did here when I just quickly did it somewhat mentally, somewhat on paper, is I just said, what's 10% of 820? It's just 82. And then I subtracted that from 820, got 738. So these are the two numbers I need to add up. So this should hopefully be the answer. If I didn't make any mistakes. Yeah. All right, next. Diama earns a 4% commission for the first 30,000 of sales he makes per month. He makes 5% commission for the portion of sales over 30,000. Remember, I'm representing 4% as 0.04, not 0.4, not 4. If he makes 5% of the commission over 30,000. So if he sells 38,000, then he's taking 5% of the 8,000 on top. How much will he earn in commissions? And that's it. I think, let me think here for a second. I can do this mentally too. So 4% of 30,000 is 1,200. It's like multiplying this by 4, which gives you 120,000, and then just move the decimal spot once, twice over. So you get 1,200. And then this one, it's like you multiply it by 5, right? So it's 40,000, and then move the decimal spot once, twice over to give you 400. And there it is. There's the total, 1,600. Next, the Earth has a mass of this. Let's see. Times 10 to the 24th. The volume of the Earth's ocean is approximately this. The ocean water has a mass of that. Okay, the volume is irrelevant, right? Because they're just throwing this out there as a red herring. But it's the percentage of the mass of the water to the mass of the Earth. That's what they want to know. So really, we're just dividing this number. Hold on. Oh, wait. No, we do need that. Sorry. This is the density. Hold on. So I need to multiply. Let's back up for a second. Good thing I caught that. So we have one, they made this look like this. So this is my total volume. 1.03. Wait, does that make sense? Yeah, I think that makes sense. Okay. And then, so this is kilometers cubed, and we want the mass over 1. And so if we multiply this by the density, which is this, right? These guys cancel out, and we get the total mass of the entire thing. So 1.34 times 10 to the 9th. 1.34 times 10 to the 9th times 0.03 to the 12th equals this. And then we divide that. We take this number and we divide it by the total mass of the Earth. 6 times. I always put parentheses to keep it safe, make sure there's no weird order of operations thing that happens that's going to throw the answer off. Yep, I think that's it. Multiply it by 100, or I'm just moving the decimal over twice, and then boom. So it's to the nearest 100%. It's 0.02%. That seems oddly low, but no, I guess that makes sense. Let's see. All right, that's correct. Okay, next. It's probably true. I bet you a lot of times they use facts and things that are real, so that's kind of a fun fact. The mass of the ocean, the oceans and the water on Earth is only 0.02%. It's crazy. Okay. I just thought it would be higher. The table above gives the quantities in moles of atoms and 1 mole of glycerol and the approximate mass in grams per mole of those atoms. To the nearest percent, what percent of the mass of the mole of glycerol, what percent of the mass of the mole of glycerol is from oxygen atoms? Okay. Of atoms and 1 mole of glycerol. Okay. So 3 moles. man, I can't remember what percent of the mass of the mole. I'm just trying to remember what moles are. I guess you shouldn't have to know that for the SAT, but I'm just trying to figure this out. Okay, so anyways, what percent of the mass of the mole of glycerol is from oxygen atoms? I think this is what we have to do. We have to convert all of these to grams and then take the grams here over the grams of the total. So it's like oxygen is 3 moles and we have to convert it to grams. So we multiply by this mass, which is 16 grams over 1 mole. This is for oxygen. Oops. Equals 48. So the oxygen makes up 48 grams. Hydrogen makes up, let's see. We don't have to, I mean, you can see we're just multiplying across. Just going to write it out for the heck of it. Equals 8 grams, and then carbon equals 36 grams. So we add these all up. 8, 16, 22, 9. So it's 92 is the total. So what percentage is oxygen? So it's 16 out of 92. Right? Oh, what? Not 16 out of 92. What am I talking about? 48 out of 92, this value. To the nearest percent rounds up to 52%. We have multiplied by 100, of course, right? 52%. Hey. Okay, there we go. That is it for a quick little live stream this Saturday. Oh, you guys couldn't read the question. Hold on one second. It's too small to read? Because usually I've zoomed in. I'm sorry about that, Jerome. Let me take a look at this size here. Probably watching. Okay, thank you for letting me know. If you guys also otherwise feel similarly about that these questions are too small. I know some people have mentioned that to me in the past, but I feel like the majority seem to be able to read it. Let me know, and I can play around with some different formats to try and improve the size of the text. Okay. Thank you guys so much for watching. If you like this video, please click that like button. And if you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you all next time. Take it easy.